Welcome to Space Engineers Refineries Explained. In this video, we will cover the basics of refineries for those new to space engineers. From there, we'll move on to more detailed aspects of refineries for more experienced players. I've been playing for quite some time, and even I have learned some new things while creating this video. In the end, hopefully, we will help answer the grand debate of speed versus yield and what is the most optimum setup. Maybe not so much that, but hopefully we'll give more insight on how refineries actually work. But enough of that, let's get started. Okay, when you start a survival scenario, as opposed to just some of the scenarios in there, so you're just doing a default survival start, you'll start out with probably something like this, which is the standard drop pod, and it will have in it a survival kit, a small grid one, much like this. It's hard to see in this, so what I've done is put it on a rotor so that you can see it. This is the survival kit small grid. It has two ports in the front, a big port in the rear, and it is your catch-all for when you first start out. You can assemble in it, you can refine in it, and you can heal and all that jazz. But it is also part of what we consider our group of refining assemblies. And what those assemblies are there's 3 different assemblies that can refine material, not including mods. The survival kit, which can only do stone, the basic refinery that can do stone, iron, nickel, silicon, cobalt, and magnesium, and then the refinery that can do all materials. And the note at the bottom here, with Warfare 2, the heavy industrial release, a new skin was released for the refinery. It works exactly the same as the regular refinery, it just looks different, and this is what it looks like. Notice it has stairs and some platforms. It's actually pretty cool. And one of the little features that sometimes often gets missed is at the top of the stairs here, there's this little access panel that you can access the inventory with. So I dig it. The only downside of it is that there's no port on the bottom, and so it really only works in the stand-up configuration, whereas the regular old refinery we can put on its side, and we can put into a lot of different configurations. And again, it has that port on the bottom that lines up with this port that's on the top. So those are our essentially 3 basic refining assemblies. Now, as I said, the survival kit can only do stone, and how it does it is that it does it in kind of a hybrid assembler method. So what we would do is put our 1k of stone in our survival kit in the inventory, and then in the production tab, which is 3, where you normally with your assembler, you would select this ingots and you would request to make, say, 10. So 10 of these ingots will process 1,000 stone, which is convenient. That's how much stone we've put in here. Now I have to just kind of show that there's no difference between the small grid and the large grid. I've set them up both along with a basic refinery and a regular refinery, and they all have 1k of stone in them. So 1k of stone, 1k of stone, 1k of stone. So what we're going to do is then run a test that's going to start all of these up at the same time and process that stone. And I'll do that right now. And we can look on this board here and we can watch as they work. Now I'm going to press this button that turns them all on. And this chart will kind of track which ones are running and which are not. But what we can see is the large grid and a small grid both use 200 kilowatts to process, and they're the last to finish. The basic refinery finished at 330 kilowatts, and the regular refinery probably finished before that. In fact, it probably finished so fast it didn't even register on this board. And what we learn is that when they process this the stone into ores, it will make 14 gravel, 30 iron, 2.4 nickel, and 4 silicon. And if we look on the board here, that I have here, per 1,000 stone, 1k stone, 30, 14, 4, and 2.4. Now here's an interesting fact with the basic refinery. Notice the however. The basic refinery is only producing 21 iron, 9.8 gravel, 2.8 silicon, 1.68 nickel. And we can see that if we were to go into this right here and see, it did not refine the same as the other ones did. But the survival kits refine the exact same small grid and large grid as the large refinery did, which is right here, which is interesting. So the only difference in the amount of yield, and that's an important word here, yield, the only difference in yield is between, there's no difference in yield between the survival kit and the refinery. There's only a difference in yield with the basic refinery. The only difference between the refinery and the survival kit is the amount of time it took. And if we look at our little board here where I actually broke out the times through calculation, the survival kits took 11 seconds. The basic refinery took 5 seconds, and the regular refinery 2.6 seconds to refine 1k of stone. So that's pretty fast. But you may be saying, hey Discodex, what does that mean in regards to like a full ore? Well, first off, like we said, the survival kits can only do stone. So the only things we have to really look at is the basic refinery and the refinery. Now the basic refinery does run at like a lower power requirement at 330, but it is slower and it does refine at a smaller, lower yield. And we can see that when I run the second test that is doing it on iron. So I have 1k of iron in here and 1k of iron in there. I press my magic little button, turn those on, and we probably won't even see the industrial refinery register because it processes so fast. Oh, it did show up. And then we'll see the industrial refinery turn off. Here soon. Shouldn't take too long. So our industrial refinery shut off, but our basic refinery is still processing, and now it's finished. And what we can see is that this only did 490, but the industrial refinery did 700. So let's look at our results board here. And what we can see is at the bottom of this board, basic refinery 490 ingots took 25.6 seconds, and the regular refinery 700 at 12.8. So the basic refinery takes twice as long as the refinery. The survival kits take roughly twice as long as the basic refinery, but the basic refinery refines at 2/3 yield, and maybe I'll spell yield properly. Okay. Than all of them when it comes to processing stone. Well, that's great and all, but what about, so that's iron, but what about the rest of the ores that we do? So the rest of the ores, we can do other ores in the basic refinery, but we're going to try to avoid doing that. Like I said, we can do also nickel, silicon, cobalt, and magnesium. But what we find is that we're already hitting an issue with only 2/3 the refinery rate or the refinery yield than what we do with a regular refinery. Now what we do is if we are look at per 1k or for all of the other ones, we get, like we shown in the previous example, we get 700 for iron, we get 700 for silicon, 400 for nickel, 300 for cobalt, 100 for silver, 10 for gold, 10 for uranium, 7 and 5. What that means is for 1k of ore that we get, the ingots are only these amounts. And that's kind of important when we're trying to, say, make a jump drive or make missiles out of platinum, whatever it is that needs these required materials, that we have to get significantly more ore to get less of the ingots from it. But that's not all of the problem that we have to deal with, because the refineries process the ore itself at different rates. So what we have is what we call consumption, which is the rate at which the refinery processes the ore. And then we have production, which is the yield that comes from the processing of that ore. So we can see in the board, on this board here, and I won't go through all the numbers, but we can refine stone per minute super fast in a refinery. The next fastest is iron, then gold, magnesium, and we notice that at the bottom, platinum, cobalt, and uranium are the slowest. And that slowest is on the processing of the ore. It doesn't relate so much at this time to yield. This is just in the front end consumption of the ore. The refinery is slower on those other elements. Then you add in the fact that the yields on some of these is lower. You get where you can see why something like magnesium, even though its refining rate is fairly high at 469 per minute of ore, but that ore is going to only yield 7 ingots per 1K of ore processed. How that plays out, I'm going to do a little experiment with this. I have put in all of these refineries 1K of each of the ores. So refinery 1 stone, refinery 10 uranium, 2 iron, magnesium, cobalt. As you can see, they're all 1K. Now if the refineries processed all the ores at the same rate, I'd push this button and they'd all process and they'd all finish at the exact same time. But we don't see that. I press this button and you hear the refineries kick up and you see all of them start working, and what's going to happen is that stone one's going to shut right off right away because this stone process is super fast. And not too far behind it, the iron one itself will go to idle, and then subsequently in about another minute the gold one will turn off. In fact, actually, so what you'll see is over time the gold one will go back to idle, then the magnesium, silicon, nickel, all the way down to the uranium one, which takes, for 1K of ore in each of the refineries with no changes, will take 17 minutes and 6 seconds, which is quite a long time. And in the process of that one ore, 1K of ore, all we're going to get for, say, uranium is 10. For platinum, it's worse, it's only 5. So what you end up with, and we'll come back to this just to kind of prove our point, is if you take the rate of consumption, how long it takes the refinery to process the ore, and the yield that it generates, you get this refining yield per minute number that I've created. And you will see that iron obviously is at the top. Now I didn't put stone in here because we don't get a stone ingot, we only have an iron ingot, but we have a breakdown of the stone at the bottom that you can either screenshot or refer back to this video for. But essentially this comes out with the overall speed of refining and to an ingot. So iron obviously is the fastest and platinum is the slowest. And this why it will seem like when you throw a bunch of magnesium into your refinery, it seems to take forever, even though it's, you know, not the slowest to process, but it yields so little. And why gold is perceived to be very, very slow, but yet its ore processing rate, consumption, is actually pretty high. 1K of ore will actually be processed, you know, the third highest in 1 minute and 43 seconds. But because it yields so low, it actually seems to take a long time. And that's significant when we start looking into things like what's next, which is talking about modules. So with the full-size refineries, we have the ability to use these things called modules. We have a speed module, a yield module, and a power module. And the speed module does exactly what it says. It increases the speed. It will affect the ore consumption. Essentially, every full speed module, and note it's a module of 2 slots, and they can be configured in any way on the back of the refinery, and you can even actually split them across. However, that also splits that functionality of that module. So if you were to put one module on half of a refinery, it'd only utilize half of that module's capability. And another thing to note too here is you can tell when you've mounted it, because one side will show green and one side will show yellow. When it's not hooked to anything, which you see in my little display here, they're all yellow. Now the yield module will actually increase by a small percentage the amount of yield that we gain. So the speed handles on one side of the refining consumption, and the yield handles the other side, production. And what it will do is increase the amount of yield that we get for a particular ingot. And then finally the power module, which is just decreasing the power usage by a refinery by 50% of each module. So that being said, the first module will reduce the power consumption of a refinery by 50%. You add another module, it'll drop it to 25%. You add a third, and subsequent. And so how that plays out is I've set up a little demo element here. And what I did was put a few configurations in here. The first one being all 4 slots being speed. The next 2 speed, 2 yield. 2 speed, 2 power. 4 power. 2 yield, 2 power. 4 yield. And then finally no modules, so that we can just see a comparison. And then I have a board that will show the power utilization that happens when I turn them on. So I'm gonna go ahead, I'm gonna sit in the seat, and I'm going to turn I'm going to basically, they're all on, but basically what I'm doing is adding the material to the refineries. And then what we can see is that, so the first one that uses that 4 speed is now at 2.8 megawatts of power in comparison to a standard 560 watts that the refinery uses. With the 2 speed, it's at 1.7 meg, and then 2 speed 2 power, it's 750, so on and so forth. So you can see that the speed is impacted by the power is impacted by how many speed modules we use, and that is reduced by the amount of power modules we use. In fact, if you look at the number 4 refinery, we're only using 112k of power to refine the exact same amount of material. Now, for this I call it the gold standard because I'm using 10k of ore in each of these for refinement, and the reason being is that 10k of ore with the refinement rate, the yield output of 10 means that I should have 100 ingots in the output for each. Now, because I'm running 4 speed, I can look at this first refinery here, and it's still processing. It'll take a little bit of time, but it only takes about 4 minutes for it to process. And so what I'll do is I'll take you to the kind of results board and show you what actually we get. So for that first refinery that has 4 speeds at the top, we'll get 100 ingots out of it, but it'll be at the cost of a power rate of 2.8, but we'll get it in 4 minutes 17 seconds. In the second refinery that's got 2 speed and 2 yield, that 2 yield gives me 141 ingots versus the 100. In fact, actually, if you look down to number 6, we get a full 200, a full 100% increase when we use 4 modules, which is significant, which means that we only have to mine half as much ore to get the same amount of ingots out. But with those 4 yields, we don't get any kind of time increase in the rate that the ore is processed, because like I said, the speed module affects consumption of the ore. The yield module affects the production of how much ingots you get. And so therefore, that's how, when trying to figure out how you want to set up your different configuration that works best for you, that's what to consider, is how much ore you can actually mine will determine how much, yield you want. How much time you want it to take determines how much speed you add, and how much power that you're able to provide to that refinery determines how if you need to add power modules or not. Now down below I have what I call the bonus ones, which I didn't run in the demonstration element there, and it's just a bunch of different configurations that some people may consider, and I'm kind of staying focused on this in case someone wants to screenshot it or refer back to this video. But the first refinery in the bonus, 3 speed 1 yield, it yields me 119 at 2.4 megawatts in 5 minutes. And then the 1 speed 3 yield, 9 minutes. The 1 speed 2 yield is 9 minutes, but 141 ingots. 2 speed 1 yield, 119. So you can kind of see the yield will determine how much ingots we get. The speed will tell us how much time it will take, and the power modules affect how much power we use. Now the one I have started, refinery 3, is what is called what I call a balanced configuration. It's a decent amount of yield, so we get a high yield, 41% increase. We're reduced power, and it's a little bit more than what it is to run the refinery by itself, but it is not very high. But we're refining that at 9 minutes 40 seconds, so it's a good balanced refinery. Another good one is refinery 5, where we're actually running at lower the standard refinery rate. We have an increased output, we get 19% more yield, and we're still running at 9 minutes and 40 seconds. So it's still another really good refinery configuration. Where this comes into play is it comes up to you, but the biggest thing that I want to point out is just adding 1 speed module cuts your time in half, whereas any more than that with the speed modules, you get a time increase, but you don't see it as significantly as you do with adding just that first one. So when adding more than 1 speed module, usually the case for that is that if you're trying to refine something that is very, very slow in its ore processing, in other words, something low on this list like cobalt, platinum, or uranium, or is something that you need just so super quickly that you have the power and you just can't wait. So this one should be close to done. What we can do is look at the different yields that we have here. So here's our stone. It's the standard out that we've seen before. Obviously our uranium one's still running, and that's expected, and that's going to be running for a while. But our iron 700, magnesium 7 as expected. The cobalt's still running, which was expected. 700 on silicon. The platinum is still running. So that's our top 3. 400 on nickel, 100 on silver, 10 on gold. And that equates pretty much to what we have on our board here. And the ones we're still waiting on, uranium, cobalt, and platinum, that makes sense. So we'll be waiting a while on those, because The slowest one that's already finished was silver, so everything after that's like 12 minutes. And so that's why I said is that if you know ahead of time that you're going to want to process platinum, cobalt, or uranium, and you need to do it in a really quick fashion, those are the ones to consider where you're going to want to increase the amount of speed modules you run versus yield or platinum. Now, some have argued that because the fact that yield reduces the amount of ore that you actually need, that it may be better to just run a whole bunch of yield modules than it would be to run power modules. So I've set up this little experiment, and I started it before the stream started. And what this is this basically is 6 different refineries with different configurations. The first one being all speed, and the idea here is that what it takes to get one jump drive. Now the sunlight's kind of getting on the screen here, but of parts that require gold ingots, disregarding progression, a jump drive requires 1,000 superconductors, which is 0.67 ingots per, so 670 ingots, and 20 gravity components, which is 3.3 ingots per, or 66.6 ingots, for a total of 736.6 ingots of gold required to make a jump drive. Note that the yield modules require superconductors, which requires 13.4 ingots per module, or 1340 ore, but we're going to disregard the fact that we're just going to assume that the yield modules are all, or the material we need to make them is already in place. So that being said, for all speed we would need the full amount of ore, because we're not running any yield, so we're going to need all the ore it would take to reach that 736.6 amount of ingots. In refinery 2, we replace one of them with a yield, and because of that, our ore amount is reduced to reach that 736. In fact, actually, because of the way that the game calculates it, even though we have a yield rate of 119%, we actually end up needing just a tad bit more ore than the calculation. But what we'll see in refinery 3 and refinery 4 is actually we need a little less than the calculation, because our yield modules are 2 and 3. But we notice is each time we add more yield modules, we reduce the amount of ore that we need to get our total static ingot count of 736. And finally, refinery 5 is all yield, which we need literally half the amount of ore required. And then refinery 6 is just that pristine model, or not pristine, but our balanced model out there. And this shows the amount of ore that we need. Now I started the test a while ago, and what I noticed is the timings are not what expected. In fact, actually you see refinery 5 is still working even though all the other ones had finished, and the refinery 5 is that all yield one, which is back here. As you can see, they are all started at the same time, but it's still processing. It's still got a ways to go. And so to save time, I've actually put the results on a board back here, and I've done these tests multiple times. That's how I know exactly how much ore actually is needed in those. And what we see is with 4 speed modules, it takes 31 minutes. With 3 speed modules and 1 yields, we get an ore reduction of about 11,500, but it still takes about the same 31 minutes. 2 speed and 2 yield, about 6 more minutes more, but still not a whole lot of change there. The biggest amount of change kind of comes a bit with an extra 5 minutes for the 1 speed 3 yield. But when we're at 4 yield is the hugest jump at 20 minutes with 62 minutes. And notice that our balanced one is at 54. It kind of comes in like second to last. So kind of middle of the road here is 2 speed, 2 yield at 37 minutes. And we notice, like, so the biggest consideration at that point is the power jump. And we notice is like with the 4 yield is that we're only using the static 560 kilowatts for that refinery. And that doubles into when we, or almost doubles when we go into the one. Actually, I think it's a full double of the power requirements there. But in refinery 2, it's not that bad, or excuse me, refinery 3 is not that bad at 1.6. So that balanced 2 speed, 2 yield seems to be the kind of optimum choice between the amount of time that you gain, the power that's required, and the ore that's required. So it's something to consider when that. But in the answer of all yield versus all speed, speed wins. Unless you just don't have access to the ore. And that, my friends, is Refineries Explained. I hope you got something out of this. I know I did. I learned a lot from setting up this tutorial. With that, thanks for watching, and if I don't talk to you before, I'll see you next time. Goodbye.